Hey everyone, welcome back. So guys, previously we have built flight operation service, but we haven't implement API for flight search. Now in this video, we'll implement API for flight search. So inside this search service package, I'll create one class flight search service. And now let me create here. First, let me convert this class to interface. Let me write here interface. And now let's create one method that can return pageable flight instance response. Pageable flight instance response. Okay. Then search flights. And let me provide here flight search request and pageable. Now let's create this flight search request class. Create this class inside the com.josh payload request. Let's click on OK. And inside this, we need to provide departure airport ID. First, let's annotate this class with the getter setter, no args constructor, all args constructor, and builder. Then let me provide here departure airport ID, arrival airport ID, arrival airport ID. Okay, so let me provide it ID. Then departure date. And let's give it local date. Let's annotate this class with not null. And if it is null, then we need to throw the exception with departure date is required. Departure date is required. Okay, like for which date do you want the flight? That is nothing but departure date. Now let's provide the passengers. Private integer. This is the number of passengers. And let's annotate with minimum. So minimum value should be 1. At least one passenger is required if you want to book the flight. At least one passenger is required. Then cabin class type. Like in which cabin class do you want to book the flight? Private. Okay. So first you will fetch the flights, then you will book ticket inside it. Okay, so let's provide here cabin class is required. Let me now provide the filter parameters here. Filter parameter. Guys, this is optional, okay? If you want, you can provide, either you can leave it blank. Filter. and let's provide here a list of long airlines. And minimum price, then maximum price. Then departure time range. Arrival time range. Okay, so guys, inside the departure time range and arrival time range, will provide a string like if you do want flight in morning, afternoon, evening, or night. And according the morning, afternoon, evening, and night keywords will provide the time range. Like for morning, you can say it uh, 6 to 9 p.m. or 12 p.m. Then afternoon 12 to 5, or evening you can say 5 to 9. Then in the night you can say 9 p.m. to 12 a.m. etc. Whatever. Okay, so we'll provide that range later. For now, let's write here. Now max duration private integer max duration. Now if you want only like 4-hour flight, okay, not more than 4 hour, or if you want only maximum 2-hour flight, it should not the maximum it should not exist, it should not more than 2 hours, okay, time duration of the flight. So if you want that, you can also provide. Now let's provide sort by private thing sort by and sort order. Okay, now let's create the IMPL class for the flight search service, since we have created the request. Now let's create flight search service. And let's implement this method. Now guys, we'll use here flight instance specification. Okay, instead of direct JPQL query, we'll use here specification. So first let's create the sorted pageable sorted pageable equal to apply sort pageable request dot get sort by, and we need to provide a sort order as well, request dot sort order. Okay, Now let's create this method apply sort. As this method will return the pageable. Let's do one thing, create method apply sort. Okay, it's created pageable sort by and sort order. For now, let me return null. Okay, and now let's create here sort direction. Though sort will import this sort from the Spring Framework data domain. Sort dot direction equal to, if DSC equals ignore case sort order. That means user wants to filter flight in descending order. So let's provide the sort direction here descending order, else sort direction is ascending order. Now let's create here sort equal to sort by equal to null or sort by dot is blank. Okay, if sort equal to null or sort dot is blank, then what I need to do is I need to provide the default sort by and direction departure date time. And else we'll use here switch case according the input data. So first let me convert into lowercase sort by dot lowercase. If case is arrival, then sort dot by direction. Okay, if case is arrival, this sort by, if user wants to sort by arrival, then here we'll provide the direction like it's ascending or descending, then arrival date time. Then if case is duration, then we'll use here JPA sort. JPA sort dot unsafe, and let me use here direction, and guys here we'll use timestamp difference. Okay, so times timestamp different. Okay, so guys, this function timestamp different will count the difference between departure date time and arrival date time in minute. Okay, according this it will sort it Like if a direction is descending, then it will sort in descending order, else ascending order. Now a default we need to sort by direction departure date time. Let me use here time, departure date time, arrival date time. Okay, if not match any cases, then default we need to sort by departure date time. That's all. Now why it is okay, first let me return here page request of pageable dot get page number, pageable dot get page size, and sort. Okay, so now why I'm getting this error, let me fix the syntax. Let's give it here sort by direction departure date time. Okay, let's fix this. Else we'll use the switch case sort by dot to lowercase. Okay, then I'm using this and I need to provide this colon here. Okay, so apply sort method is now ready. Let's move to the next step. So now guys, we need the flight instance specification. So let's create one flight instance specification. Do one thing inside the service. Let me create one package specification. Okay, now inside this, I'll create one class flight instance specification. Okay, now let's do one thing. Let's create a set of flight status. Now these are the status of like if flight is cancelled or completed or diverted. Okay, then we need to exclude that flights from our search result. So that's why we need to create here a set of flight status. Set of flight status. Excluded statuses. Now set of flight status dot cancel flight status dot completed flight status dot diverted. Now let's create flight instance specification. Okay, let's create the method. Public method it should be flat static. Guys, this is the empty constructor we have created here. Now this is the actual method for specification, build search specification. 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 Flight instance. Let's import this flight instance. Then build search specification. Build search specification. Okay, now let's provide here flight search request. Flight search request and request. Okay, so let's return here root query and callback. Let me create first empty predicts, list of predicate, and it will be predicates. Let me create new array list. This is the empty predicates. Predicate I have imported from the Java util function. Yeah, predicate. Predicate. Okay, so guys, I need to remove this predicate and let's import from the persistence criteria. Okay, this is the actual predicate. Great. Now let's provide here step by step query. So our first specification is get only active instances. Only active instances. So let's add predicates. Predicates dot add callback. If callback will return is true, and root dot get is active. Here we need to provide the field name. Okay, is active. Now second predicate is exclude this terminal statuses. Exclude terminal statuses. So here you can see we have list of excluded statuses. We need to exclude it. How we can do that? Predicates dot add root dot get status. And let's write here in excluded statuses. Let's provide the excluded status is not. Okay, so I don't want the flights whose statuses are cancelled, completed, or diverted, because cancel flight will not fly anymore, or diverted will also not fly. Then completed fly has complete their journey. So now it's completed. Okay, it's not scheduled anymore. Now in third step, flight must still be in the future. Flight must still be in the future. Okay, we need to check like returning flight is should be in the future. Predicate start at callback dot greater than root dot get departure date time. And when guys we can say that it is in future, so root dot get departure date time, it should be greater than local date time. So let me provide the present time, local date time now, local date time dot now. And one parenthesis is missing. Now it's this is this parenthesis. Now for this root we have this, for this here we have, and okay, it's completed. Now in the fourth step guys, we need to match for origin airport. Okay, so for is origin airport. So let's provide predicate dot add callback dot equals root dot get departure airport ID. Departure airport ID. Okay, and let's provide here request dot get departure airport ID. Now in the fifth step, I need to write destination airport. Now let me add here predicate add callback dot equal root dot get arrival airport ID. It should be double R. Okay, so destination airport callback should be equal root dot get arrival airport ID and request dot get arrival airport ID. Okay, now we need to these are the required specification. Okay, now we can apply optional filter. So optional filters. 6 departure date. Okay. So guys, we need to filter it by like user wants the flights on which date, like 25th, 26th, 31, etc. 4th March, 5 April, 10 May, etc. On which date he wants the flight. So we need to filter that here by departure date. Departure date. So let me write here condition if request dot get departure date not equal to null, and inside the request departure date is required, we have already provided, so we don't need to write this if condition directly. We can first let's grab here start of the day time, start of the day from request dot get departure date. Departure date. Departure date. Okay, now let me get here departure date and at start of the day. Okay, so departure date start of the day and departure dates end of the day I want. So let me now write here and of day equal to request dot get departure date dot h time local time dot max. Predicates dot, now let's add this into the predicates, callback dot between. Okay, it should be so departure date should be between the start of the day and end of the day. Let me write here root dot get departure date time and start of the day and end of the day. So flight's departure time should be between start of the day and end of the day. Now let's check for passenger. So here we'll check guys seats availability. Passenger count is required. Okay, so what we can do is we can add predicates dot add callback dot greater than or equal to root dot, let's provide here get available seats, available seats, request dot get passengers. Okay, so guys available seat should be greater than or equal to total passenger. If available seat is less than greater than less than total passenger, then we won't allow this flight to come in the search result. Okay, now let's filter by airline ID. So let me write here step 8. Okay, let me do it like this. Step 8. Here we'll filter by airline ID. So if a user wants flight only from the specific airline, he can filter it by airline as well. Here now we can give if condition if request dot get airlines not equal to null, and not request dot get airlines is empty. Then predicates dot add root dot get airline ID. And let's write here in request dot get airline. Okay, so guys, request will be the list of airline ID. So this root dot get airline ID should be in this list. If it is not, then don't return that. Now step number 9. Is departure time range. Departure time range. Let's write here if filter label is filter label time range. Guys, let's create one method here for is filter label time range. Private, it will return static boolean is filterable time range, and it will be the string range. Let's return here range not equal to null, and range dot is blank. Then range dot equal ignore case any. Okay, now let's check here is filterable time range. Request dot get departure time range. Apply time range a predicate. So let's create one method. Private static void apply time range predicate. Okay, so here let's provide the list of predicates in root list of flight instance, criteria builder, criteria builder. This is nothing but criteria builder CB. Let's import this root as well. Then date time field, string date time field, and let's provide string time range. Okay, now let's create one variable for hours. Expression integer hour equal to criteria builder dot function. Let's provide here hour integer class and root dot get date time field. And let's use here switch case. Time range dot to lowercase. Let's provide here case morning. Guys, here, as I told you before, in morning we'll provide the hours time range like hours is between 6 to 11. Okay, so let's use here redis dot add criteria builder dot between. Hours should be between 6 to 11. Okay, this is morning. Then afternoon hour should be 12 to 17. Predicates dot add criteria builder dot between. Hours will be 12 to 17. Afternoon. Okay. Now case evening. Predicates dot add criteria builder should be between hours 18 to 20. As first let me finish this, then I will explain each line. Now let's write for night as well. So case NIGHT night. Predicate dot add. Here guys we need to check criteria builder or. Okay, here we'll provide the two conditions. Like criteria builder, first condition is criteria builder dot greater than or equal to hours and 21 and less than. Second condition is Okay, after this second condition is callback criteria builder dot less than or equal to hours 5. Okay, and default, let's return empty. So guys, in this switch case, we are checking if case is morning, time range dot to lower case. Okay. In time range will provide like morning, afternoon, evening, or night. So this keyword will come from the front end. If keyword is morning, then we'll check predicates dot add callback dot between hours, means time should be between 6 to 11. If it is afternoon, then time should be 12 to 17, means 12 to 5 p.m. Then if it is evening, then 18 to 20, means 6 p.m. to 8 p.m. And if time is night, then it should be less greater than or equal to 21, means from 9 p.m. to 5 a.m. in the morning. Early morning, actually, not morning, but early morning. Okay, and the default we are returning just empty. Now let's complete our 10th, 9th step. Let's check here. Apply time range predicates a route and callback. Then departure date time. Departure date time. And let's provide a request dot get departure date time. Now 10th step is arrival time range bucket. Arrival time range. So guys, for arrival time range, let me provide a similar is filterable time range, request dot get arrival time range, and apply time range predicates route criteria builder and arrival date time request dot get arrival time range. Then for maximum duration, maximum flight duration in minute. So if a user wants like only flights which are not longer than 4 hour or not longer than 3 hour or 2 hour, so that kind of filter we need to provide here. If a request dot get maximum duration not equal to null. Now expression integer duration minutes equal to criteria builder dot function, and let's provide here timestamp difference. and let's provide here integer dot class, then callback literal. Let's provide here minute and root dot get. Let's provide departure date time. Departure date time. Then root dot get arrival date time. Okay, so guys, this will return us the time difference in minute, date time sign. Now let's add this in predicates at criteria builder dot less than or equal to duration minute and request dot get maximum duration. Okay, so guys, now first let's understand this maximum flight duration in minute. So if user wants only flights which are like less than 4 hour, less than 3 hour, or less than 2 hour, then we'll apply that filter here. This method duration in minutes. So criteria builder dot function timestamp difference. This function will return the difference between this departure date time and arrival date time in form of the minute. Okay, now we need to check this minute should be less than or equal to request dot get maximum duration. Okay, so now let me query dot distinct, let me make it true, and finally return here criteria builder dot and predicates dot to array and new predicate on 0th index. Okay, it should be, why it's giving me the error. Inside this we have the return this. Predicates dot to array, new predicate. I guess I forgot any. Okay, I need to provide here colon. So guys, and now a flight instance specification is ready. Okay, now it's time to use this flight instance specification. We'll use this build search specification method inside flight search IMPL. So let's go to flight search servers IMPL, and after this sortable, let me use here specification flight instance specification. Let's import this flight instance. Import specification and use here flight instance specification dot build search param, and let's provide here request. Okay, now let's create page with the help of this specification. We can fetch all the flight instances in form of pageable flight instance. So db page equal to flight instance repository. We need to annotate this class with the service and the required action constructor. Flight instance repository dot find all. Let's provide the specification and sorted pageable. It will have a find all method, and what we need to specification create method find all in flight instance repository. Okay, do we need to create this method? Actually, this method is already exists in the flight repository, but why it's giving me this error? Let me check the import, like import of page. Oh, this is okay. Flight instance repository. Flight instance repository dot find all. Need to provide here specification and sorted pageable. Let me remove this. Go to the, okay, let's remove this as well. Find all. Let's provide here pageable. Okay, and first parameter specification. Build flight instance specification dot build search specification. Provide a request. Now let me check what is it's returning. Okay guys, so we need to provide the JPA specification inside the instance repository, flight instance repository. So let's provide that. Now currently we have this two parameter like flight instance and second is long. Now let's provide the third parameter, JPA specification executor. So let me provide here JPA specification executor flight instance. And now I don't need to provide this long, so let me remove it. And that's it. Why I'm getting this error? We need to extend JPA repository, then flight instance, long, JPA specification executor, and flight instance. Okay. And okay, I forgot to give this closing tag here. JPA repository, flight instance, then long, and then let's give the comma. Okay, now it's done. Now let's go to the flight search service IMPL. Okay, and you can see the error is gone now. Okay, now let's check here if a DB page is empty. DB page dot is empty. Then we need to return here page dot empty, and let's provide sorted pageable. Now let's define here list of flight instances. Flight instances. Instances equal to new array list db page dot get content. Okay, still typo error. Let me check. Instances. Okay, now let's create here fair map. So map long fair response. Let's import the fair response. Fair map equal to new collectors, new collection empty map. Okay, now let me import the map and collections. Actually, we don't need this new keyword. Great. Now guys, we'll filter here flight instances with the price range if provided by the user. Okay, so let's first do one thing. Check here if request dot get cabin class not equal to null. Not equal to null. Then let me create here one final boolean variable as filter, as price filter. So we'll check here if a user wants to filter this flight instances with the price or not. So if he wants to filter, then inside request he will provide the minimum price, get minimum price not equal to null, and request dot get maximum price not equal to null. And now let me provide here fair response merge fair map. Okay, So we are creating here a merge fair map hash map. Now let's create one empty list for filtered flight instances. So flight instance filtered equal to new array list. Now let's write here for loop. Guys, will loop through all the instances. Okay, currently you can see we have instances here. So let's loop through all the instances. Flight instance and let's get here cabin class ID. So let's create one method resolve cabin class ID. Resolve cabin class ID. So guys, we'll create this method resolve cabin class ID, which will return us cabin class when we provide cabin class name, cabin class type, request.get cabin class, and of which aircraft do you want the cabin class. So we'll provide that aircraft ID here. Flight instance dot get flight. Inside this flight we have aircraft ID. Okay, now let's create this method resolve cabin class ID. Or instead of guys directly also we can use. So let's do one thing. Okay, for now let me return here null by default. Okay, we'll implement this method later. For now let's focus here. Now we'll check if a cabin class ID equal to null, cabin class ID equal to null, then we need to continue. Okay, skip that instance because it doesn't have any cabin class ID. Else fair response fair equal to pricing. Okay, let's create the pricing client. We don't have pricing client inside this flight operation service. Let me check. Okay, I don't have any pricing client. Let me check. Pricing client, and it should be interface. Now let me annotate this with the fan client. What I need to give is a name equal to pricing client. Okay. Now guys, here we need method that can get the get the lowest fare. So let's go to the pricing client. Fare response, get a lowest fare for flight and cabin class. And let me give here path variable long flight ID. Let's give path variable long cabin class ID. And let's provide here slash API fares lowest flight ID, cabin glass, and cabin glass ID. Okay, API fares lowest flight, then flight ID, cabin glass ID. Now what I need to do is okay, give me just 1 second. Now guys, we'll use this method here to grab the lowest price. Pricing client dot get the lowest fare for flight ID and cabin glass. So let me provide here instance flight instance dot get flight dot get ID, and second parameter I need to provide the cabin glass ID. Okay, now let's check if fare equal to null, then continue. Okay, if it's not null, then we'll check if has price filter. If yes, then we'll filter it. So first let me grab the price from fare, lowest fare. So fare dot get total price. Then if price equal to null, then continue. We can skip it. Now let's check if request dot get minimum price not equal to null. So has filter where we have provided this as filter. Yeah, there you go. Request dot get minimum price, request dot get maximum price. Both are not null. Okay, so guys, these are not null. Minimum price and maximum price. So what we can do is without writing this condition, we can write the logic here. Okay, so let's do one thing. Remove this and price less than request dot get minimum price. Okay, then we need to continue. So let's do one thing, put this inside the if condition. If price is less than request dot get minimum price, then we need to continue, we need to skip that instance. So we are giving here continue. And for maximum price, if price is greater than request dot get maximum price, then we'll continue. Okay, all right. So guys, here user wants the minimum price is this, but it request dot get minimum price is greater than this price means there's a fair price, then we need to continue. And user want the maximum price. Okay, if price is greater than this maximum price, then he will continue, means he will skip that instance. He don't want that flight. Now let's give merge fare map dot put uh, flight instance dot get flight instance dot get flight dot get id, and let's provide the fare, and inside the filtered also will add the flight. Okay, now after this, fare map equal to merge fare map, and instances equal to filtered, instances equal to filtered. Great. Now let's check if instances is empty, then return page empty sorted. If instances is empty now, then return the empty page. Okay, it should not the comment. Great. Now finally guys, we need to convert this instances into list of flight instance response. And here, where is the get lowest? No, resolve the flight id. Where is the resolve flight id method we are using? E4 and resolve cabin class id. So here you can see we have resolve cabin class id method. Now instead of this resolve, directly we can use here seat client. So let's do one thing, use here seat client dot inside the seat client we don't have this method. Okay, so let's do one thing, create method inside the seat client, get cabin class by aircraft id and name. Okay, so let me provide here inside the seat client, let me import this cabin class response, cabin class type. Okay, so get mapping API cabin classes aircraft id name and cabin class. So get cabin class by aircraft id and name. So if this method is not present inside the seat service, we'll implement it, but for now let's finish this. Seat client dot get cabin class by aircraft and name. Now it will return the cabin class response. So let me provide here cabin class response. And now let's create cabin class id. Cabin class id equal to cabin class response dot get id. Okay. Now guys, let's create one method that can convert this list of instances into uh, instances a response. Okay. So let's do one thing. First, let's use that, then we'll do it. After this if condition, we are returning here null. Okay, so here let me create the list of flight instance a response. A response is equal to let's write the method name enrich with external data. So guys, we need to provide here external data. Like currently in this instances we have aircraft ID, but we don't have aircraft detail like aircraft name, model, etc. And we have flight ID. Actually flight data we have, but don't have the airline details. It has only airline ID currently. So we need to enrich with the external data. So that's why we kept method name is enrich with the external data. And now let me give here instances and fare map. So with each flight instance response will set this lowest fare. We'll grab it from the fare map. Now let me create this method. Now let's return here new page impl response sorted pageable db page dot get total elements. And now this resolve cabin class ID is not being used, so let me remove it. Okay, and now it's time to implement this enrich external data method. So let's implement this method. It has a list of flight instances and fare response, fare map. Now we are creating here map along airline response, airline response, airline cache equal to new hash map. So guys, temporary will store the airline data inside this airline cache, which we can use during this method. Okay, so that we don't need to make a new database call if we have this cache. All right, now map along airport response, and let's provide airport cache and a new hash map. Then let's create for aircraft cache. Okay, this three data will add here long, and aircraft response, aircraft cache. flight instance response results equal to new array list. And guys, since we are know the size of this result array, let's define this instances dot size. Instances dot size. Okay. Now let's loop through each instances, and let's provide here aircraft response. Aircraft equal to aircraft cache dot compute if absent flight dot get flight dot get aircraft ID. Else make a DB call in airline client. So airline client dot get aircraft by ID. Okay, so guys, what is the meaning of this method? First, we need to check if inside this aircraft cache aircraft is exist with this ID. Okay, then no need to make the DB call, just grab that aircraft response. But if it is not exist in this aircraft cache, then make a DB call and add into this cache. Okay, and same guys we need to do for airline airport, for arrival airport and departure airport. So let me provide for all these three. Now let me check a location client I have. Yeah, location client also I have, and inside this get airport by ID. Okay, same for the airline guys. Let me show you the flow as well. Here you can see the flow. Fetch aircraft using cache. So if key is in cache, then don't make the API call and just return the value of it. If this key is not present in the cache, then make a DB call and store value in cache. Okay, and example also guys, you can see here, if a user make a call for 101, so currently it's not present in the cache because cache is empty, you can see here. So it will make a DB class and store that inside the cache. Now cache have this 101 with aircraft A. Okay, and again if it's make a request for 101, then it don't make the DB call, instead it directly return from this cache. But if input is different this time 202, then it will make a DB call, store that value inside a cache and return it. Okay, so that thing we are doing here. Now let's create the list of flight instance response. So we already have, so inside this result will add. Okay, so first let me create the flight instance response. Response equal to flight instance mapper flight instance to response, and flight instance aircraft airline departure airport and arrival airport. Now response dot set fare, we need to set the fare here. Okay. Uh, let's check the flight instance response. Inside the common library, we have payload. Inside payload, we have response. Flight instance response. And okay, you can see we have commented this. So now let me uncomment this, and we can set the fare map dot get. We need to provide here flight instance ID. Okay, so let me check. I have created a fare map. So yeah, this is the fare map, and get flight dot get ID. Actually, I need to provide here just flight instance ID. Okay, because this is for the flight instances. So that thing need to do. Or if we use here flight flight instance dot get flight dot get ID. Then flight instance dot get flight dot get ID. Okay, that's how we can use here. Okay, now guys, we need to add this result. Okay, so results dot add response. Results dot add response. So inside this result we have added it. Now finally we can return that result here. Results. Okay, this method is also done. Now guys, two things we need to keep in the mind. That is nothing but, first let me check why its king is still okay, asset null. Okay, no worry. Now guys, let's go to our price client. This method is not exist in our pricing service, and this get cabin class by the aircraft. So first let's go to the pricing service and implement that method inside the pricing service. Okay, we'll create payment. This is the pricing. Open this service minimum, sorry, main class. Inside the service we have fare service. Get the lowest fare per flight we have, but what I want is get, it will return the only single fare response, and get fare, get lowest fare for flight and cabin. Now let's provide here long flight ID and cabin class ID. Okay, now let's create a list of fare. First we'll fetch all the fares equal to fare repository find by flight id and cabin class id. Let's provide a flight id and cabin class id. Now from this fare list we'll grab the lowest fare. How you can do that? We'll store it into the lowest fare variable. Now fares dot stream, and let's use here a minimum function comparator, and let's give comparing double. Fare get total price. And let's give or else null. And let me return here fare mapper to response lowest fare. Okay, now we need to create the controller for this. So let's go to the controller, fare controller. Now inside the fare client, actually pricing client, we have this. So let me copy this, go to the fare controller, get fare, get lowest fare. Let's define here. Okay, and copy the, create one body here. Now here we'll return response entity dot OK fare service dot get lowest fare for flight id and cabin. Flight id and cabin class id. Response entity, let's wrap this here. Okay, now let me remove this. Okay, so get lowest fare for flight and the cabin class method is ready now. Now what we need to do is inside the seat client we have this method get a cabin class by aircraft and id name. Let me check this is exist in a seat service or not. If not, then we need to create one. Let's go to the seat controller. Actually it's in cabin class controller. Get cabin class by aircraft and aircraft id and name. Okay, so same we have get cabin class by aircraft id and name. Then this API cabin classes aircraft and name, aircraft id and name. Okay, so this already exists. Now we don't need to create this. Great. Okay, so yeah guys, the flight search service method is ready. Now let's create one controller for this. Inside the flight operation service, inside the controller, let me create one flight search controller. Now let's annotate with the rest controller, and request mapping. Endpoint will start from API slash let's start with only API for now. And now okay, or guys, let me remove this just to give. Let's remove this request mapping and annotate with the required asks constructor. Okay, now let's create one method here. Guys, we need a flight search service instance, so let me create one and create one method that can return a response entity page flight instance response. And let me write the method name search flights. Let's annotate with the keyed mapping. API. Here we'll define the endpoint. API flights and search. Flights search. So guys, we need to provide the parameters like departure airport ID, arrival airport ID, etc. So let me provide all this here. And let's import this cabin class type. And at the last, let's provide the pageable. Pageable and pageable. Let me return here null for now. Okay. So what it's give? Type of query page does not have type parameter. Flight instance response entity page. Okay, no problem. Now let's implement here. Here guys, we'll create the flight search request. Okay, so let's create the flight search request. Import this. We don't have alias, so let me remove it. And with the response entity, okay. Response entity, okay. Flight search service dot search flights. And let me provide here request dot so actually only and second parameter guys, with the request we need to provide the pageable request and pageable, so it will return the required type Josh payload and response entity domain page. Let me remove the page, this page, right? Now let me import this domain page. Okay, now it's done. So guys, now let's understand this whole controller. So inside the request parameter, we are accepting departure airport ID, then arrival airport ID, then departure date, passenger, cabin class type, then a list of airline IDs, airlines, then minimum price, maximum price, departure time range, arrival time range, maximum duration, sort by and sort order. And this aliens we don't need, so let me remove it. Okay, and this guy's airline minimum price, maximum price, departure time range, arrival time range, maximum duration, short by. These are the optional parameter. Either user can provide from the front end, either he can skip those parameters. But these parameters are required. Okay, it's not optional. User has to provide it. It is mandatory to search a new flight. Okay, so then we are creating here flight search request. Flight search request dot builder. We are setting departure airport ID, arrival airport ID, departure date, passengers, number of passenger, cabin class type, then airlines. Okay, this is the list of airline IDs. Minimum price, maximum price, departure time range, arrival time range, maximum duration, sort by, sort order, and then we are building the object and pass it over here. Okay, now let's open our Postman and check is it working or not. First, let's start all the services. So let me start all the services one by one. Okay, we need to wait a couple of seconds till it's starting. Let's do one thing. Open Dockerized. Actually, currently we don't need the Docker engine, but still let's open the Docker and run the Kafka so we don't get any type of error in the console. So we'll start here Kafka container. Actually, we have created this Kafka container when we have test the Kafka in our project. So let me run that existing container and do not create new one. Let's minimize it. You can see all the services are running one by one. Now let me open service registry in the browser. So service registry dashboard code is 8761. And let me remove one by one all the services get registered themselves with the Eureka discovery. Currently booking is down. Okay, and now booking is also done. Flight operation service. Okay, now let's go to the Postman. Inside the flight service, flight instance, we have search flight. You can see here. So API flight search and availability, departure airport ID, etc. we have. So currently, guys, I will provide only those endpoints which are required. So let me provide only those required parameter: departure airport ID, arrival airport ID, then departure date, passenger, and cabin class. So departure airport ID, arrival airport ID, and passenger cabin class. Okay, number instead of number of travelers, let me provide here passengers. Now passengers, then cabin class, let me give just economy, and departure date, it's 2026. Month is, let's use in April 04. Let's give 2 or 5, and let's hit the endpoint. So we are getting API flight search availability. We don't have this endpoint. Let me remove it. And now let's hit not found. ABI flights. Actually, it should be the flights. Okay, and it says unauthorized. So guys, now let me logged in first. Go to sign in, or inside the login we have this credential. Let log in and grab this JWT token. Okay, now go to the search flight, authorization, provide JWT token, save it, send the request again, and we are getting could not resolve attribute departure time. Let's go to the parameter. It should be departure date. Okay, so departure time range. Okay, these are not departure date. It's a departure date. Departure date. Departure time of I guess guys, we have made mistake inside the maybe specification. Let's check. We have used a departure time. So let's check the flight instance field. It's departure date time, not only time. Departure date time. Okay, so instead of time, let's use departure date time. Okay, and now let's send the request again. And it says internal server error. Let's check which error we are getting inside the flight operation service. I guess we got inside the API gateway. What is it? Connection refused. Okay. Okay guys, so this error occurred because when we made this changes, now our flight operation service is restart, and it will take some time to register with the Eureka. But guys, I got one more problem, like departure date time, arrival date time. This is okay, but here you can see I'm using departure time, so it should be departure date time. Okay, departure date time. Yeah, now let's go to the flight operation service, and let's do one thing. I think we need to restart the server now. So let's restart the flight operation service once, and then we'll check the endpoint again. Okay, let's go to the service registry, restart, and you can see flight operation service is there. Let's do one thing. Go to the postman, hit this endpoint again, internal server. Okay, so let's wait a couple of time and send the request again. Maybe this is because of the connection issue. Now let's do one thing, send the request again. Okay, still we are getting okay guys, and now it's fixed, but we are getting content empty. Okay, so we are not getting any flight for now because I don't know the date. Okay, so currently on this date, we don't have any flight in our database. So I will check on which date I have flight. According that, I will send the request. So let's get by airline ID. Let me send the request. It's giving me unauthorized. Airline admin JWT token. Let's send the request. And it will return the list of flight instances. And now let me check the departure date. Arrival airport. So departure date time. We have 4th April. Sorry, 6th April. We have flight on 6th April. Then second flight we have in this also in 4th April. Sorry, 6th April. Now let me check the next flight. 6th April. 6th April. All the flights I have on 6th April. Now let's go down. Check last one. So guys, last we have 20th April as well. On 20th April. Then 13th April as well. So let's search those flights. Go to the search flight. First, let's search for 6th April. Okay, I'm not getting anything. Now let me check for 13th April. Still, I'm not getting. Okay, so arrival airport ID, guys, we need to check. Let's go to 16th. Okay, this is 13th April. What is the arrival airport ID and departure airport ID? So arrival airport ID is 2 and departure airport ID is 1. So let's go to search flight. This is 2. Arrival airport ID. Departure airport ID is 1. Now let me send the request, and I got the error that says does not contain an instance for service seat price. Okay, so let me check inside the client. First we have airline client, it's working. Location client is working. Pricing client, so instead of pricing client, we need to provide here pricing service. Okay, let me check once. Pricing service, yeah, you can see pricing service. We need to provide the name, and for seat price also we have seat service. So let me change this as well. Seat service. Now we need to restart the flight operation service. Let me check if it's auto reload or not. So okay, it's auto reload. Let's wait a couple of seconds and restart this. Now we have flight operation service. Now we can make request on this endpoint again. So let me send the request. It will take some time, and there you go, guys, inside the content. Now I have maybe how much? 1, 2, 3 flights I have. Okay, so guys, it's working perfectly fine. Now if I give the 14th April, let me check on the 14th April I have any flight. So I don't have any flight on the 14th April for departure airport 1 and arrival airport 2. So guys, our search flight endpoint is working fine. Okay, so that's it for this video. Now let's meet in the next video, guys. Hey everyone, in this class we are going to understand what the config server is and why we actually need it in microservices. Let me ask you something. Imagine you have 10 microservices. Each one has its own application.yaml. Everything looks fine, right? Now one day your teammates say we are going to production. Suddenly database password change, Eureka URL change, Redis host change. Now what do? You open 10 different files, change the same thing 10 times, rebuild 10 services, redeploy 10 times, and worst part, if you make one small typo in one file, that service crash in production. This is a real nightmare in microservices. So let's understand the real issue. Right now, every service manage its own config. Like a user service has its own DB configuration, then config service has a same DB configuration, and payment service also have the same thing again. So it's repeat same data everywhere. So if one things change, you have to update it everywhere. And if you want a different config for dev, staging, production, now you have multiple files for each services. And sensitive data like password, API keys are sitting inside every repository, and that's not good. Okay, that's not the best approach. So what is the solution? We don't keep config in every service. We move everything to one place. Config server is just a separate microservice whose only job is store all configuration and give it to service when they start. So guys, earlier every service reads its own file. But now after implementing the config server, every service asks config server for the config related data. Service don't own config anymore now. Config server owns it. Now question is, where does this config server store data, configuration related data? So simple answer is Git repository. So all configs stored in one Git repository like user service.yaml, booking service.yaml, payment service.yaml, flight operation service.yaml, seat service.yaml, pricing service.yaml, etc. So now one repository controls the entire system config. Let's see what happens when service start, like how it will work. Okay, so in step 1, user service start. Before doing anything, it asks config server, give me my config. So that means if we want to start our user service, config server should be up and running. Only then our user service will start. In the next second step, config servers read from the Git repository, send config back, and service start normally. So service doesn't depend on local file anymore. Everything comes from the config server. Now you might be thinking, why Git? Why we are storing data in Git related to config? Because Git gives us history, version control, rollback, and team collaboration. If config breaks production, it just revert commit and it's done. Config is now treated like code, safe, trackable, and professional. Now another powerful feature is environments. You can have user service.yaml, user service dev.yaml, user service prod.yaml. Okay, inside the user service dev.yaml, you will have a development related config, and in production prod.yaml you have production related config, and in the service.yaml you have default configuration. If service runs in production, it will get configuration from prod.yaml. If service run in development, then it will read configuration from the dev.yaml. Okay, shared config, default config, prod specific config we have. One repository handle all the environments. Now let's say connect this to our system. Okay, so let's connect it with our system. Config lives in GitHub. Okay, our GitHub repository. Config server run on port 8888, 4 times 8. This is the port of our config server, and you can give any number, like you can give 4 times 9 as well, whatever you want. It registered with Eureka then. Okay, so first config lives in GitHub, config server run on port 8888, 4 times 8. Then it will register with the Eureka. Okay, so what will be the flow? Service starts, then it will ask Eureka find config server and gets the config from it and send me or give me my config. So that will be the flow. So this is how real microservice systems work in production. Guys, you can even test this in browser. We'll do it when we implement a config server in the next class. Okay, you can just hit the URL and you will get config as a JSON. We'll do it in the next class when we implement config server. Now, very important. What should we store here into config server? So we'll store data related DB config, URLs, API keys, Kafka and Redis config. And what data will not put here is business logic and actual code. If it changes based on environment, it belongs in config server. Now, let's quickly wrap up. Config server centralize all configs. No more editing 10 files. Use Git repository for version control. Service fetch config at startup. Support multiple environments easily. So, if you change config in one place, entire system updated. And that's the power of config server. So that's it for this video. Now let's meet in the next video and implement config server in our project. Hey everyone, welcome back. In this video, we are going to implement config server in our project. We'll follow this 4 steps. In the first step, we'll create project and set up. Then in the next step, we'll create Git repository where we can store config related data. In the third step, we'll move configuration from a local file to config server. And in the fourth step, we'll test the config server. Okay, so let's go to Spring Initializer and initialize the project for config server. In group, I will give com.josh, artifact ID. Let me give the config server, and let me remove this config server from the last and keep package name only com.josh. Packaging will be jar configuration YAML, Java version is 17. Now let's add the dependency. Guys, here we need 2 dependency. One is Eureka Discovery Client. So first let me add the Eureka discovery client. And second dependency is config server. Config server. So here we have the config server. Now let's generate the project. Okay, and download this project inside the cloud directory. Now let's navigate to that project. Now we need to unzip this file. So let me extract all. Okay, now let me cut down from it here and paste it over here. Now, since we have unzipped the project, we don't need this zip file. So let me remove this. Okay, now let's go to the IntelliJ IDEA, and inside the cloud you can see we have config server. Okay, now we need to register this config server in parent aggregator as a module. So let's open the parent aggregator pom.xml file. Here guys, we have service registry and API gateway. Now with that, let's register config server as well. Let me provide the config server. Okay, great. Now let's go to the pom.xml of config server, and here we need to provide the parent aggregator detail, like parent group ID is com.josh, then parent artifact ID is cloud. Let me provide the cloud, and version I will give this. So let me provide the version here. Now guys, since parent group ID and this config server group ID is same, I can remove from the here, and I can keep only inside parent block. Now let me provide the name as well of this project. So it's a config server, config server. Now this property block I don't need, so I will remove this, and this SCM license and URL also I will remove this block. And guys, here you can see we have the dependency management. So our dependency manages from the root parent aggregator. So we don't need this dependency management block here. Let me remove that as well. Okay. Now let's see. Here we have the config server project. Okay. And let's open the YAML file of it. And first let me provide the port. So server.port is 4x8. Okay, port is nothing but 4x8. Now here I need to provide cloud config server and git, then URI. Okay, here we'll provide the git URL, GitHub URL. Then let me give clone on start true. Okay, now let me provide the Eureka detail as well. Eureka instance prefer IP address true. Okay, and we need to provide client detail as well. Service URL default zone. So our Eureka is running on localhost 8761. Okay, when you start the Eureka server, it will run on 8761. Okay, great. Now let me provide register with Eureka. Let me give true, and fetch registry also let me give true. False, actually fetch registry is false. Okay, great. First step is guys done. Okay, from this fourth step we have done the first step, like create project and setup. Now second step is create git repository. Okay, so let's go to the browser, go to GitHub, and I will create a new git repository. public Git repository actually. Let's give the name Josh Air Config. Josh Air Config. Okay, visibility is public. Now let me create this. And it's creating the repository. It's created. Now let me copy this remote link, git remote add origin, and this is my repository link. Now guys, I will go to the let me close this as well, and let's open this. Now inside this, like I have the Docker Compose and microservices. So here I will Docker Compose directory and microservices. So guys, here I will create a new directory for Josh Air config. And let me open this with let's open it with the VS Code. Okay. Now let me do one thing. For now, just create here application.yaml file. Okay. Application.yaml file. Application.yaml file. Okay, now let's go to the IntelliJ IDEA. Let me open any service, user service. From this, I will grab the database configuration. Okay, common database configuration. Let me show you what is common. So guys, here you can see this JPA related data. Okay, like Spring, JPA, Hibernate, Auto DDL. This will be same in every service. Okay, and this is not same because this URL has the different DB name for each service, and of course this username is same, but will not keep that details. Let's just do one thing. Use this JPA Hibernate DDL auto this configuration. Let's copy this configuration and provide inside the default application. So here we have the default application. Now let's use here Spring. Okay, then we have JPA, Hibernate, and Auto DDLs. Guys, it's not perfectly working with the VS Code. Let me open it again with the IntelliJ IDEA. Okay, so inside the IntelliJ IDEA, extensions will work perfectly because IntelliJ IDEA is specially made for the Java developers. Okay, now here you can see we have Spring, JPA, Hibernate, and DDL Auto. And also one more thing, guys, we are not providing the Eureka client detail. So now we need to provide the Eureka client detail as well. So that we have already provided inside the config server. So let me go to the config server, and you can see we have provided Eureka client service URL. So that thing also I will copy and provide inside the application.yaml file. Okay. Now this two configuration I will keep inside application.yaml file because this application.yaml's configuration will be used by every services. Okay, will not add this in each services. Now first let's finish the uh, creating a repository. So what I'm gonna do is, let me open the terminal and maximize it. If you remember, we have copied the URL for adding Git repository. Okay, let me remove this. Clean, clear. Now let's go to again Git repository and copy this URL again. Let's go to IntelliJ IDEA, Git remote add origin. Okay, so it will add the remote in our Git repository, but Git repository is not initialized. So let me initialize first empty repository using git init. Okay, now inside this empty repository I can add the remote. Okay, now remote is added. Now let me add this. So git add, and now I can push it to the GitHub using this remote. Git push origin master, and it throw me, what is this? Okay, give me just 1 second. Okay, so guys, inside the Git repository we have main. So let's do one thing, add this inside the main file. Git push origin main, and here also we are getting this error. And one more thing guys, before this we need to commit it. So we haven't git commit, we need to commit the changes. Git commit -m, and let me provide the message that created application.yaml file, create application YAML. Okay, now let's push git push origin master, and okay, so now it's added to the GitHub. Let's go to GitHub, let's refresh it, and there you go guys. You can see now we have application.yaml file. Okay, great. Now again let's go to the GitHub, sorry, IntelliJ IDEA, and here we need to provide our GitHub URL. Okay, so let's provide our GitHub URL here. Go to the browser, copy this, again go to the IntelliJ IDEA. In URI I'll provide github.com code with Josh R config. Okay, now let me load Maven changes, and I can start the config shower. So let's go to here. Let me start my config shower, and it will take couple of seconds guys, so we need to wait till that. Let's wait. And what it says, cannot execute request on any unknown server. So of course our service registry is not running. Let me start the service registry as well, and config server is guys now running, you can see on this port. Okay, now let's go to the browser, and let me open the Eureka dashboard. Okay, and in Eureka dashboard you can see config server is registered. Our config server is running on 4x8. Okay, so whiteable error page. Okay, great. Now again first let's see So guys, you can see we have finished the first point, second step as well, like create git repository. Now next step is to move configuration from a local file to config server. Okay, so let's open our IntelliJ IDEA. In all the services, okay, not any one services, but in all the services like airline core service, ancillary service, booking service, we have configuration in local file. So let me first start with the airline core service, and let me open main resource application.yaml file. Okay, so guys, what we will do is we will move this configuration and server pod as well, of course, inside the config server. How we will do that? First, we'll create one file. Okay, so let me cut this. Let's go to the Eureka client. Okay, let me do one thing, cut this. Okay, let's do one thing, we'll cut it step by step. So what I'm gonna do is first let's go to the Josh airline config. Now inside this, guys, this is the folder where we have created Josh air config directory. Okay, now in this directory we'll create airline core service YAML file, airline core service dot YAML. This is not a valid Java class name, of course, so let me close this. Guys, actually we need to create the file name. Okay, now first let's provide the port. So let's cut this port detail from the local file and move inside the config server file. Now second step, let's cut this as well, and here let me use Spring. Okay, now let's cut this Eureka related configuration as well. Let me cut this and provide that detail here. Okay, now guys, we have moved all the configuration. Now our local application YAML file has only application name. Now you may thinking we can move this name inside the config server. No guys, this name should be kept in the local YAML file. Why? Because this name will match to this file name to fetch the configuration data from the config server. Okay, if both name file name and application name will not match, then your airline core service will not be able to fetch data from the config server and it will crash. Now one more configuration, guys, we need to provide inside the local YAML file. We need to tell it basically like from where you will fetch the configurations. So let's provide the config import, and here we need to provide optional config server uh, and the URL where our config server is running. Okay, so option we are providing optional. That means if a config, if you get the config server, then it is fine. If not find the config server, still you can start executing the airline core service. Means you can start the airline core service if you didn't find the config server as well. But if you feel like your airline core service is really dependent on the config server, without config server it will not run, you can remove the optional. Okay, that is great. One more thing, guys, inside this airline core service, now we are using the fetching the config server. So what we need to do is we need to, guys, provide uh, dependency inside pom.xml. Okay, config client. So let's search for config client. There you go, Spring Cloud config client. Let's add it and load Maven changes. Let's go down here. You can see where we have, there you go, starter config. Great. This is done, guys. Now let me do one thing. Let's start the airline core service and check is it working or not. So okay, one more thing, guys, still it will not work because we haven't pushed the configuration inside GitHub, right? So what we need to do is let's go to here, because guys we have moved this configuration from local YAML to config server YAML, but still it is not pushed inside the GitHub because our local YAML file is reading the config server and our config server is reading the GitHub repository for configuration. Okay, so now let's add this into the GitHub, means post inside GitHub. So let me add comment here git add, and let me now comment this as well, -m create airline core YAML, and now I will push this code to GitHub git push origin master. That's it. Now we can, sorry, this one, we can again run this airline core service. So let me start this airline core service, and still it's not able to read this data. Okay, so what is happening here, guys? Application A double P LICATION application and airline core service dot YAML. Okay, let's do one thing. Let me start the config server again, restart the config server once, and okay, Tom, config server is up and running now. Well, let me start the airline core service. Okay, still it's not able to read the database configuration. Guys, it's not working because we forgot to annotate our config server's main class with at the rate enable. So at the rate enable config server. So let's go to the config server and open the main class, actually config server application. And guys, we need to enable here config server. Okay, now what I'm gonna do is I will restart the config server file, config server service. Okay, so let's wait, it's restarting, and there you go, it's up and running on port 8888. Now let's go to the browser, go to Eureka dashboard, refresh it, you can see config server is running. Okay, now let's go back to IntelliJ IDEA, and now I will restart the airline core service. Okay, and it will take couple of seconds to restart. Let's wait till that. And there you go, guys, and this time it's up and running without any error, so it's able to read the config server. So guys, now let me explain once what happening is here. Let's open our airline core service. Okay, so whenever we start the airline core service, guys, let me comment here, start airline core service, it will, guys, read configuration from the config server. So it will check config server is up and running or not. So it will go to the config server, config server. Now let's go to the config server. Now config server will look into this repository for this name, like airline core service.yaml file. So config server will look into this repository and check is airline.coreservice.yaml file exist or not. So let me show you that inside the git repository, airline.coreservice.yaml file. Yeah, is it exist? Now what we'll do is whatever configuration inside it, it will grab those configurations and provide it to the airline core service. Okay, and then our airline core service will start normally without any error. Okay, now one more thing, guys, let's go to the config server Josh Air config directory. Now currently, guys, you can see we have here JPA Hibernate DDL auto. Okay, this thing will be repeat inside user service as well. So what I will do is I can remove this from here. Okay, and I can put this inside application.yaml file. So Spring JPA Hibernate DDL auto updated. Okay, so now whenever airline core service request for the configuration, a config server first look for the application.yaml file, and whatever configuration exists inside application.yaml file, it will grab that and then it will check to the related file. So it will combine both configuration. So like when we run now application airline core service, first it will grab the application.yaml's configuration and then it will grab this airline core service YAML configuration and combine both and provide it to the airline core service. Now let's write for the user service. So here I will create one file, user service dot YAML. Okay. Now inside the user service also, guys, we need to add same thing. Let's open this, go to the user service. Now let me minimize this airline service, open user service YAML. You can see here we have this data, so let me cut all and paste inside the config shower, and this name part I will copy and let me remove from here. This name part, guys, I will keep inside the local file. So let me provide here name Spring application name user service, and whatever name you have provided here user service, the same name you need to give to the file user service YAML. Okay, and this JPA related configuration will come from this application.yaml, so we don't need to provide it. Okay, now again let's go to the user service, and inside the pom.xml first we need to add one dependency, a cloud config, sorry, cloud config client. Let's add it. Okay, user service work is done. Now let's do same for the seed service. So first let's go to pom.xml. Let me add the configuration. Here config client. Let's add it. Now let's open the application, copy all this, cut from here, go to here, let me create here new file seed service.yaml, and let's add this. So where is the application name? Here you can see seed service. Copy this. So guys, this same name you need to provide to the file name. Okay, now let me remove this JPA as well. Okay, now go back to here and provide the application name. Maven reload changes. Spring service is ready. Now let's go to the pricing service. Inside pom.xml, let me first add the config client. Let's click on OK. Now let's open this main source application.yaml. Reload Maven changes. Cut this from the pricing service YAML, and here let me create new file pricing service.yaml. Okay, let's provide this detail. I will copy this and remove the application name from here, this JPA related configuration as well. Now let's go to the local pricing application YAML and provide the application name. Okay, now pricing service is ready, guys. Now let's open the payment service. First let's add the dependency config client. Now let's open the application.yaml file, copy this, go to the config shower, create one payment service.yaml. Okay, now I will copy this, remove this application name from here, this JPA configuration as well. Okay, now let's go back to the YAML file. From local YAML file, guys, I will remove all the configuration. Just keep the spring.application name. And let's reload this. Okay, so payment is also done now. Now let's open the location. So for location also same. First let's add the pom.xml dependency inside pom.xml. We'll add config dependency, config client, and then let's open the application.yaml. Let me copy this, go to the config shower, create one file. This is for location service. Okay, so let me give here location service.yaml. Okay, let's provide. First, let me copy this, remove the application name from here and this deep JPA related data. Now, let's go to the local YAML file of location service, remove all and just keep the application name, location service. Now, location service is ready. Now, let's open the flight operation. Go to the pom.xml and add here config client. Okay. Now let me open the application.yaml of it. Reload Maven changes here. Now let's go to the, this is flight operation service, right? So let's go to config directory, create one file, flight operation service .yaml. Okay, pasted this. Let me remove this JBA, this as well. Now let's go to the local YAML file and remove all this. Just keep the application name. And same for the booking service. So inside pom.xml, I will add the dependency config client. Then go to the application.yaml. Let me copy all this. Let me create one booking service.yaml file. Okay, and let me remove this application name from here and this JPA related data as well. Okay, now let's go to the local YAML file of the booking service. So from this, I will remove all the configuration, just keep application name and load Maven changes. Now let's open the ancillary service, open pom.xml, add the dependency, that is nothing but config client. Okay, now let's open YAML file of the ancillary service. Copy all this, go to here. Let me create the file ancillary service.yaml. Okay, let's provide all this detail. Let me do one thing, remove the application name and let's move this server port in top. And also I will remove this JPA related configuration. Now let's go to the local file, remove all this and let's load the Maven changes. Okay, so guys, we have update all the application.yaml file of all the services. Okay, Now guys, we have moved configuration from local YAML file to config server. Let's go to the config servers config directory, and what I'm gonna do is I will add this inside GitHub. Git add, git commit, move all config data to config server. Okay, now we need to push this as well. So git push origin master. Let's go to the GitHub now and refresh this. You can see now we have all the files like airline core service, ancillary service, application YAML, booking service, flight operation service, location service, payment service, pricing service, seat service, and user service. Okay, now let's go to the IntelliJ IDEA. And guys, now what I will do is I will start all the services. Okay, so let me click on this button and it will start all the service one by one. And let's wait. Okay, airline service has not running, and ancillary also give us error because guys, config server is started now. So I hope now all the services will run. Oh, still it's giving error. Any services are not run. Let me restart this airline service. Okay, first let's wait to finish all this. Seat service is also not running. And user service is also not running. What user services says? Config server property to your configuration. So guys, we didn't provide the config servers configuration, like from which server you need to fetch the configuration. So we need to provide that detail. If you remember, inside the airline core service we have provided. So let me open the application.yaml, and you can see we have provided config URL, config servers URL, like from this server you need to fetch the configuration. So now let's add this in each service YAML file. So first let's open ancillary service application.yaml provided here. Then let's provide inside the booking service application YAML, because we are not telling guys service that from which server you need to fetch the configuration, and without telling, how the Spring Boot will know? Okay, it's not a magic. We need to tell Spring Boot that you need to fetch configuration from this server. Okay, now let's open the location service as well. And resource, let's provide, and then let's open the payment service. Then let's open the pricing service. Then let's open the seat service. Okay, and now let's open the user service as well. So guys, by providing this config server URL, we are telling that you need to fetch the configuration from this server. Okay, now let's restart all the services one by one. First, let's restart the airline core service, then ancillary, then we need to start the booking, then flight, location, payment, pricing, seat service, and user service. Now let's go to the browser and check Eureka dashboard. So inside Eureka dashboard, guys, you can see already this service are registered, like location service, flight operation, config shower, booking service, API gateway, ancillary service, and airline core service. Now let me refresh it once more time, and there you go, all the services are up and running, guys. So that means, guys, our config server is working perfectly fine without any error. Okay, and still the seat service has the problem. Data source URL attribute seat service. Okay, so let me check what's the problem with the seat service. Let's open seat service application.yaml file, and this is the seat service. Let me copy this. Now let's go to the config server. Okay, and here what I have is seat service. So this data source inside the Spring, and Kafka is also inside the Spring. We can verify here. Okay, now, guys, problem is fixed. Let's post this changes inside into the GitHub. Git at git commit -m fix error in seat service YAML file, and let's push into the GitHub. Git push origin master, and code is pushed to the GitHub. Now let's go to the IntelliJ IDEA and restart this seat service. Okay, it will take couple of seconds. Let's wait till that, and there you go, seat service is up and running, guys. Now let's go to the browser and restart Eureka dashboard, and you can see now seat service instance is also registered. Okay, so yeah, guys, our config server is working fine without any error. So that's it for this video. Now let's meet in the next video, guys. Hey everyone, welcome back. In the previous video, we have implemented config server. Now we'll write Docker compose file for it. So let's open our Docker compose directory inside the IntelliJ IDEA, and let's scroll down. After the Kafka, we have infrastructure. Okay, inside this infra, I will create here config server service. So let's use here config. Actually, it's not capital. Let me first create the service name, config server. Now inside this, let's provide the image detail. So guys, this image we don't have, will create this image later, but for now let me just provide the name YouTube GDS config server, and version is 1.0.0. Then let me provide the container name. So container name is YouTube GDS config server. YouTube GDS config server. Then let's provide the memory limitation, memory reservation, and CPU. Let me copy this. Guys, currently I'm not exposing any port here. If we need, I will expose it later, but for now there is no need, so I'm not exposing any port. And now let me provide the environment variable. So in environment variable will provide Spring Cloud config server git URL. Spring Cloud config server git URI. Okay, and here let me provide the GitHub URL where we have store config related data. So let me go to my config server microservice YAML file, and from that I will copy this GitHub URL and let me provide here. Okay, then we need to provide Eureka client service URL. That we have already inside all the services. So from location service I will copy. Let me copy this and let's use inside the config server. Okay, environment variable is now ready. Now we need to provide the health check. Okay, so let me copy this for health check. For checking the health, like test cmd URL -f and actuator health. Okay, let me add here config server port. Config server port is this. Now for this, guys, we need to add actuator dependency in all the services. Currently we don't have. Okay, so we'll add those, and yeah, that's enough, guys. Now let's do one thing. In all the services, let's add the actuator, guys, because we are using actuator in all the services. You can see health related. Okay, this is inside only 2. Okay, so we need to add this actuator inside the service registry and config server. So let me go to my services inside the config server pom.xml, where it is. There you go, config server. Now let me add the Spring actuator dependency. Spring actuator dependency. Spring Boot actuator. There you go. We have Spring Boot actuator, and let's reload the Maven changes in config server and service registry as well. So this is the service registry pom.xml file, and let me add here Spring Boot actuator as well. Actuator. Spring Boot actuator, here it's already added. Okay, no problem. Now let me check about the API gateway. Where is the API gateway? Let me maximize the API gateway, and okay, here I'm not using. Okay, now guys, we need to make some changes in the services. Like earlier we are commenting code related config server, like depends on config server condition service healthy. So now I will uncomment this and uncomment this Spring config import as well. Like from this server, you need to read the configurations. Okay, now in all the services, I will uncomment this. I will keep comment Redis, because currently we are not implemented Redis yet. When we implement Redis, that time we'll uncomment it, but for now we don't need it. Okay, now let's open the user service, uncomment this config server condition service healthy, and this line. Okay, same thing we need to do inside the airline core service. Like let me remove this. Okay, and let's uncomment this as well. Now let's open the flight operation service, uncomment this config server condition service healthy, and this line as well. Now here guys, I will uncomment this Kafka Spring Kafka Bootstrap server as well, because we have added Kafka as well. So Kafka related dependency also I will uncomment. Okay, now let's go to the location service. Inside the location service, I will uncomment this config server condition service healthy and this line spring config import. Okay, now let me open the seed service. Let me uncomment this. Also, let me uncomment this Kafka condition service started, and I will uncomment this as well. Now let me go to the pricing service, uncomment this config server. Guys, inside the seed service we have this 403 line as well commented, so let me uncomment that. Now inside the pricing service, uncomment this 424 line, and okay, now let's move to the ancillary service. Uncomment this 2 line first, then uncomment this 450. Now let's go to booking service, uncomment this 466 and 467, then 474, and inside the payment service 491 and 492, then 499 and 505 as well. Okay, now guys, we need to generate the image for config server. Okay, so let's go to our IntelliJ IDEA where all of our services are open. Now let's open the config server form.xml. Here we need to add the Google Zip plugin. Let's do one thing, copy that Google Zip plugin from the service registry. So inside the service registry we have earlier provided this Google Zip plugin. Let me copy this plugin and provide inside the config server form.xml. Okay, and here I will change the image name YouTube GDS config server. YouTube GDS config server. Let me verify the name. YouTube GDS config server. Okay, this name we are using, and here also we are using the same name. Great. Now let me do the reload changes, and now I need to open guys the Docker desktop to generate the Docker image. So let me open the Docker desktop. It will take couple of seconds to start, and you can see Docker engine is starting. Let's wait till that. Okay, now Docker engine is up and running. Let me go to container. I will remove this container. I don't want any container for now. Now let me minimize it. Let's go to the config server directory. So cd cloud config server. Okay, now from config server directory where our pom.xml file is live, where we have provided this Google Zip plugin detail, we need to run the docker build command. So this is nothing but maven zip docker build. Okay, it will generate the Docker image for us. uh, it will take couple of seconds. Let's wait till that. You can see 33% is completed, now 84%. So let's wait till it will finish 100%, and there you go, build success. Now let's go to Docker desktop, and inside images, guys, we can verify that image is created or not. So just YouTube JDS config server, image is created successfully. Now let's go to the Docker compose file, open it inside the terminal. Okay, and here, guys, I will start this Docker compose file. So what I can run is Docker compose up and -d, means in detach mode. So it will start all the services. Okay, and let's wait. Created, and it's waiting for the config server, because config server is starting first time. All these are we have tested before as well when we create the Docker compose file, but config server is new in this Docker compose file, so it will take a little bit time. Let's give it some time and wait. Okay, do I need to pause the video or something, because it's already 45 seconds, now it's 48. Okay, let's wait, do not pause the video. Let me wait. And it's 60 seconds, 61, and there you go. Now it's waited for Eureka server as well. Okay, so let's wait for the Eureka server as well. 81, 82, 83 seconds. Okay, let's wait. Or do I need to pause the video? Should I pause, guys? No. Okay, all the containers are up and running. Now let's go to the Docker desktop and verify once. Let's go to the Docker container. You can see we have Docker compose, and inside all the containers are running. Okay. Okay, guys, it's up and running. And now, guys, one more thing I want to tell you. Let me minimize this first. So whenever we implement the config server, that time what we have do is we have update all the microservices. Like we have moved configuration from local YAML file to config server. So all the services are get updated. Okay, and we have the old images of the services, old image of the services. So now what we need to do is when we test our Docker compose again, that time we need to remove old images, Docker images, and we need to generate new Docker images for all the services. Okay, so yeah, for now, guys, that's it. Now let's meet in the next video. Hey everyone, welcome back. In this video, we'll regenerate all the Docker images and test it with the Docker compose file. Now you may have a question why we need to regenerate the Docker images. So guys, we have add config server in all our services. So code get updated. Now we need to regenerate Docker image with that updated code. Okay, so let's go to Docker desktop. First we'll remove old images. Okay, so let me checkbox here, YouTube GDS. Actually, I will not remove the config server image, but let's remove this YouTube GDS pricing, then booking, then we have location. Okay, then service registry, then user, ancillary, payment, airline, flight, seat, and API gateway as well. Okay, so first guys, we need to remove the container. Let's go to the container, delete this container. Okay, now go to images again. Let's click on the delete and let's remove all these images. Okay, now let's go to the IntelliJ IDEA and start regenerating all the images. Let me open the terminal. Let's start with the API gateway. So first I will get into the cloud. Inside cloud we have API gateway. Okay, once I'm in the API gateway, I can run maven zip docker build, and it will start generating image for the API gateway. So you can see it's 25%. We need to wait. Okay, and let's wait a couple of seconds. %, done, 32%, 33%, and 95% and 100% done. Okay, it's 100% done. Now we can verify this image is get generated or not. So inside Docker desktop you can see the YouTube JDS API gateway image is there. This image. Okay, so now guys, let me do one thing. Create all the images for all services and come back to you. Okay, it's generating for the airline service. Now let me go to the ancillary service directory. Ancillary service. I need to go back one directory back first. Okay, from the ancillary service also I will run maven zip docker build, and it will start generating image for it. Now let me pause the video. Okay, it's 100% done. Now let me go into the booking service directory. Booking service. Now let me run here maven zip docker build command, and it started generating the image. Okay, image is generated for booking service as well. Now it's time to generate for flight operation service. Flight operation service. Run maven zip docker build, and it started generating the image. 25%. Okay, for a flight also image get generated. Now it's time to generate for a location service. Location service, and it started generating image for the location service as well. Okay, now let's generate for the payment service. Okay, and it has starting generating image for payment service. Okay, now let's generate the image for pricing service. And let's run the command maven zip docker build, and it started generating image for it. Okay, now let's generate for the seat service. Seat service, and run command maven zip docker build. Okay, 25% completed. Now let's generate for user service. Maven zip docker build. Okay, and it started for generating image user service. 32%, 33%, 81, 82, 83, 87, 90, 96, 7, 8, 9, and 100%. Okay, now let's go to the Docker desktop and verify once all the images are generated. So you can see all the images are getting generated. Now let's open the Docker Compose file. So wherever Docker Compose file lives inside this Docker Compose directory. So let me open it with the IntelliJ IDEA new window. Okay, now let's open the terminal and run this Docker Compose file. Docker Compose up, and it will take time. Service registry. Guys, we have delete images for service registry as well. Okay, let me check. Go to the Docker desktop and okay, so let's do one thing. Generate the image for service registry as well. Let me go one step back, one more step. So this will get me outside of the user service, then from the service, and let's go into the cloud. Okay, inside the cloud we have the service registry. Service registry. Service registry, or what is it? Let me check. Service registry inside the cloud. Service registry. Okay, now let's generate image for it. Okay, so it will take a couple of seconds, like 30% done, 32% done, 33% done, 85, 86, 87, 89, and 100% completed. Okay, now let's go to Docker Compose and open the terminal, run Docker Compose. First, let me clear this. Docker Compose up, and you can see it has started. So I forgot to give a detach mode, that's why I'm able to see all the logs here. Okay, no problem, let's wait. Wow, pricing DB, seed DB. Okay, payment. Okay, is it done? Because it stopped. So let's go to the browser, guys, and verify. Or now it will start creating the container for services or what. Okay, so let's wait. Waiting, container, server, service healthy, server healthy. Okay, now I'm able to see the logs of service registry. Till that, guys, it's starting. Let me open the browser. Okay, and here I will open the Eureka server dashboard, And there you go. Currently there is no instance available. Let's go to the log. Okay. It's starting all the services. Once all the services are ready, it will automatically register here itself. So you can see config server has registered itself. Okay. Now maybe location services also ready or not. Let's go to the guys Docker desktop and see any particular service log, because in here all services logs are coming. That's why we are not able to focus on any line. Let me open the airline core service, and you can see airline is started, okay, on port 5002. So airline is why not registered here. Okay, many services are registered, guys. You can see airline core service, ancillary, API gateway, booking service, config server, then flight operation service, location service, payment, pricing, seat, user service. Which are left? Let me refresh it one more time. 1 2 3 4 5 6 7 8 9 10 and 11. Okay, so we have the total 11. All the services are up and running. Now let's do one thing, guys. Open our Postman and check is it working and now ready to deploy on the cloud or not. Okay, so if this will work, guys, is it ready? We can say that is it ready to deploy on the cloud if it's work. So let's open first user service and try to sign up with RAM details. Okay, so let me send the request and wait what we are getting. Sending request, and there you go, guys, it's working. And this time all these services are not running in our local machine, but it's running on the Docker. And main thing is, guys, it's working perfectly fine. So let me copy this coupon and check for profile as well. Let me provide here and see I'm getting the user information as well. So you can see, guys, we are using localhost 5000. This is the API gateway's endpoint, and API gateway is running on Docker. Let's go to the Eureka and see 5000. Okay, so yeah, guys, since it is working fine, now we can say that our system is ready to deploy on the cloud. So that's it for this video. Now let's meet in the next video, guys. Now it's time to implement Redis in our system. In our airline system, the location service serves cities as a list of cities and airports as a list of airports and airports by ID. Now think about this. How often does a city change or airport? Almost never, right? But your API is called thousands of times. Like every time a user opens the flight search screen and every time the booking service validate an airport code. Every single call is hitting your database. But that's a waste. Today we fix that with Redis caching. Okay, so let's open our IntelliJ IDEA and start implementing Redis in our system. We'll start by adding dependency. So in the location service, let's open the pom.xml file. Here guys, we need two dependency. Okay, first one is our main dependency Redis cache, and the second one is Jackson. Jackson for Java support in serialization. Okay, so let me add the both dependency here with the comment so that you know why each dependency we have added. This is for Redis cache and this is for Java support in serialization. Alright, now what we need to do is in application.yaml file we need to add the configuration. Okay, so inside the Spring let's add data, then Redis. Okay, we need to provide here host. So guys, what we'll do is we'll start Redis on our local host in Docker, right? So let me give here local host, or let me guys give the environment variable as well. Spring data Redis. Spring data Redis host or local host. Okay, so first it will try to find the Redis host inside environment variable. If environment variable is not available for this thing, then it will use the local host. Now we need to provide the port. So let's provide the port here also guys. We'll add the environment variable. Okay, let me give it close. Inside that this Spring data Redis port, and let me give the default port 6379. This is our localhost port, and we need to provide the timeout. So guys, our system will wait for 2 milliseconds to respond to the Redis. If in 2 seconds, not 2 milliseconds. So for 2 seconds we need to provide the 2000 milliseconds. Okay, our system will wait for 2 seconds to respond the Redis. If in the 2 seconds Redis will not provide the data, then it will hit actual database. Okay, so if Redis will not work, then our system will not goes down. Now we need to provide here let use. Let me use the pool max active 8, max ID LE. Let's give 4, and then let me give minimum ideally. Let's give 1. Okay, and now I need to give the cache in the data. So let me provide here cache. Type is Redis. Okay, so guys, As I told you, this is the host and this is the port. First we are reading this from the environment variable. If not found in the environment variable, then provide the default value. Then we have timeout. Okay, if Redis doesn't respond in 2 seconds, our system will not wait for it and hit the actual DB. Then reduce pool. So guys, a reduce pool is the Redis client Redis client Spring Boot used by default. So we are guys setting up connection pool here, okay, and maximum active we have given the 8. That means at most 8 simultaneous Redis connection. Okay, then we have cache type, and that is nothing but Redis. So it's basically tells Spring Boot to use Redis as the caching backend. Now what we need to do is we need to provide the cacheable. Okay, so let me open location service main class and enable here caching. Enable caching. Okay, now guys we can use the cacheable in our methods, but before using cacheable, what we need to do is we need to provide the Redis configuration. Okay, so let's here we don't have any config package, so first let's create the package for it. Redis config. Redis. Okay, Redis. Redis config. Now inside that we can, sorry guys, let me delete this package and create again with the config, just config. Inside this config package, let me create new Java class Redis config. Okay, now guys we need to annotate with the configuration, so let me annotate with the configuration and will implement here caching configurer. Implement caching configurer. Now let's create the method public okay, a Redis cache manager. I will return the Redis cache manager. Redis like this, cache. So cache spelling is wrong. Redis cache manager, Redis connection factory we need to give here. Okay, so let's do it. Let's import this Redis connection factory as well. And now let me create here a object mapper. Mapper equal to new object mapper. Okay, now mapper dot register module. We need to give here a new Java time module, and why it's giving me remove radiant argument to call a register module. It's not a module, it's just a module, a register module. So we have import from the JSON data bind, right? So I think I need to import this object mapper. Let me remove this and import this object mapper from the faster XML. Okay, and still it's giving me error. Mapper dot register. Okay, I have made a mistake here as well. Register module. Okay, now it's fixed. After that, mapper dot active default typing. Active or default typing. Okay, we can provide here as less per subtype validator dot instance. Okay, then object default typing. Let me provide object mapper dot default typing. Yeah, dot non-final. Then JSON type info. Now JSON type info dot as property I will give. Okay, that is great. Now let's create a JSON serializer. So we have set up the object mapper with Java at time support. Now let's create the JSON serializer. Here guys, we'll use generic JSON to JSON Redis serializer. Generic JSON. Generic JSON. Generic JSON to JSON Redis serializer. Not a builder, but just a serializer. Yeah, and let me give it name JSON serializer. JSON serializer equal to new generic JSON to JSON serializer, and let's give here mapper. Okay, generic JSON to JSON Redis serializer. Generic JSON. Okay, we have imported this, right? We have the builder. Okay, so let's use builder here, guys. Okay, it's deprecated, so what we'll use is guys, when I scroll over here, you can see why it's not giving me. Yeah, there you go. It says since version 4.0 it's marked for the removal and deprecated. So what we need to do is instead of this, let me remove here. We'll use it JSON to JSON. JSON to JSON. JSON to JSON. So it says JSON to JSON also deprecated. Okay, so now what we need to use is okay, this is also deprecated. So what we'll use is let me use the generic JSON. This is deprecated, right? This we have seen. Now we'll use here generic JSON Generic JSON Redis serializer or Redis serializer. Yeah, this one. Now let me give serializer new generic JSON Redis serializer, and let's give it here cache mapper. Actually mapper, sorry guys. Mapper which we have created here, this mapper. Okay, and what it says, a required type rule JSON data byte object mapper, and we have provided faster XML. Okay, so let me guys change the type of it. Okay, and here we have registered modules. Okay, so let's do one thing guys. Let me remove all this, and we'll write it again, and instead of this object mapper, what we'll use is JSON mapper. Okay, so let me write here JSON mapper, and let's import this JSON mapper. Okay, and now let me give here JSON mapper. Okay, that is okay. Now what we need to do is instead of a new JSON mapper, we have JSON builder. JSON builder dot build, and we can set fields here, like let's set the disable. In disable serialization feature, we can give serialization feature dot write detail as timestamp. Write write dates, sorry, write dates we need to give. Right, then okay, so why write date is not available? Serialization feature dot write date. Serialization feature write date is not available. Okay, so guys, in JSON 3 it will automatically resolve this. Let's use here now active default typing as a property. Okay, active default typing as a property, yeah, that is important, and we need to provide here type validator default typing. So type validator validator, and let me give default typing non-fill. Then let's give here class. Okay, now this type validator we need to create here polymorphism type validator. Let's give the type validator equal to a basic polymorphism type validator dot builder build. Okay, and we need to set here guys allow. Let me set allow if subtype, and let me give here object dot class, and type validator. Why it's giving me error? What it says, required type tools dot injection data bind polymorphic, and I have used polymorphic type validator from the injection faster link. Okay, so I need to fix this. Where is the, yeah, it should be from the injection annotation. Okay, so let me remove it and import it again. This one, injection data bind annotation. So let's fix it. Polymorphic or validator type injection data bind. Okay, and now let's import this as well. Okay, now this is fixed, guys. Okay, and we have created a serializer as well. Okay, now as a next step, I want to create the default cache config. Okay, so Redis cache configuration, and let me give the defaults equal to Redis cache configuration dot default config dot serialize key with, and we need to give here Redis serialization context dot serialization pair. Not this one, serialization pair, yeah, this one, and dot we have from serializer, we can give here new string Redis serializer, dot actually okay, so we have here this is the closing of this, and what about this? Okay, let me close this as well, closing parenthesis, yeah, this is the closing of this. All right, after that we need to provide a serialized value with serialized value with. So this is the serialized key with, and key should be the string. Now value will be the JSON. Okay, so let's provide here Redis serializer context dot serialization pair dot from serialize, and now it's a JSON serializer. So let's give here JSON serializer which we have created here. So let's give serializer this one. Okay, and okay, this closing is this, and this parenthesis closing is this. Great. Now disable caching null values. Okay, disable caching null values. Okay, great. Now we need to provide the pre-cache TTLS bucket name. Okay, so let's provide here map string Redis cache configuration Redis cache configuration, and let me import the map. Here let me give the cache configs. Cache config equal to map dot off. So this is the bucket names, airports. Okay, inside which data will store, that will decide in when we annotate our reading methods. Okay, so that time we'll provide this key. Actually not key, but this is the cache bucket name. So it's a cache name is very relevant. We can't say it key, it's a cache name. Okay, cache bucket name. So default dot entry tl and duration, let's say here of hours, duration dot of hours. 6 hours is enough, right? Let me copy this. Okay, so guys, after 6 hours it will clear the data and store the fresh data. Now airport by city, airport by city. So guys, inside this bucket will store those data which will fetch from our database by cities. Means whenever we fetch the airports by city, those data will store inside this bucket, and in the airports will store those data which will fetch by IDs, like fetch airport by ID. Okay, so let me provide this now. So we need to provide here this closing. Okay, great. All right, now guys, for all the airports, okay, whenever we want to fetch all the airports, so that data will store inside the all airports bucket, all airports. Okay, now let's create bucket for cities as well. So cities, and guys, city often okay, for city also let's give 6 hours, because city also don't often changed, city and airport both. City by code. Now let me create one more bucket, cities by code, cities by code, and that's all. Okay, buckets are created. Now let me create the Redis manager and return it. So return Redis manager, Redis cache manager dot builder build. Okay, what we need to set here, cache defaults. So this cache default, and with initial cache configurations. I think okay. With initial cache configurations, and let me give here cache config. Great. Okay, I have missed here one closing. Let me fix this. Okay, this comma I missed, and now it's fixed. So guys, now our cache configuration is ready. Okay. Um. So we have implemented this cache manager method. Now we need to annotate this method with the bin. So we need to make it bin. Let's annotate with the bin. Okay, that's all. Now as a next step, what we need to do is guys, we have already enabled the caching. Okay, yeah, great. Now we can go to the our methods service IMPL. Let's start with the airport service IMPL. Here we have method get airport by ID. So get airport by ID. Okay, and let's give here cacheable. Cacheable. Why it's not giving suggestion? Okay, cacheable. And in cacheable, we need to provide the bucket name. So cache name. You remember we have created that this name inside the configuration, right? And let's give the key equal to hashtag ID, like this. Okay, and now it's cacheable. Okay, so guys, first time it will fetch data from the database. Okay, and the next time it will use this cache data. And now next time it won't hit the database. Instead it will use store data inside the Redis cache. Great. Now let's go to the get all airports, and here also guys, I need to provide the cacheable and provide the cache name, and let's give airports all airports. Great. Now airports by city. There you go, we have the airport by city ID. Let me give the cacheable, cache name, airports by city, and let me give here name, city ID. Okay, airports by city. Okay, great. Now guys, we need to provide the cache evict. Now this is the critical part guys. Whenever we update or delete airport, so in airport and delete, so whenever we update and delete the airport, the old cache data is now stale. Okay, so what we need to do is we need to clear the bucket and restore the fresh data. So let's use the cache evict on update, cache evict, and here I need to give evict so why evict cache evict, from where I have imported this cache evict, let me check. Spring framework cache annotation cache evict. Okay, and we need to give here evict Why it's not giving me any suggestion? Okay, guys, we'll use here just cache, sorry, caching. Okay, now it will allow to multiple cache evict. So let's give here now evict equal to, and let me remove this from double curly braces to single, and now we can use here at the rate cache evict cache name equal to airports, and here we need to give the key. So let's give the ID. Okay, let me copy this cache evict. So guys, this will clear the airports bucket. Now we need to clear all airports bucket as well. All airports bucket, and all entries, let me give here true. All entries equal to true. Okay, then airports by city bucket I need to clear. So let me give here airports by city, and all entries equal to true. All entries equal to true. Great. This is done. Now let me copy this. Same thing guys, we need to do for the delete airport. So here we have the delete airport. Once the airport is deleted, we need to clear this buckets. Okay, now let's do this inside the city service IMPL. We have the get city by ID, right? So let me give here cacheable, and give here cache name, cities key equal to ID. Okay, then update city. Okay, so here caching, it will allow us a multiple cache evict. So let's use caching evict equal to cache evict cache name, cities key is ID, and let me give here cache evict cache name, cities by code, and let's give all entries true. Okay, and same caching guys will use on delete city. So let me give here for the delete city. Then we have okay, cities and city by code. Let me go to the Redis configuration, airports, cities by code. Great, so we have used that cities by code. Okay, so yeah guys, that's it for a Redis cache class. So that's how you can implement the cache in your project. Now guys, whenever you fetch this endpoint like get cities by ID, whenever you hit the endpoint get cities by ID, first time it will hit your database and grab the data from it, and then it will store inside the Redis cache. Now, whenever second time user will hit the endpoint get Redis by ID, it will not hit directly your database. Instead, it will use the data stored inside Redis cache. Okay, so that's how Redis will work. Now let's meet in the next video. Alright guys, we have implemented Redis in our location service. Now we need to write Docker compose file for this. Then we can test the Redis. Okay, so let's go to the file explorer. Okay, and inside course we have the airline, and inside that we have Docker compose. Now let me open this directory with the IntelliJ idea. Okay, and here we have the Docker compose. Now inside that I'll create one new file, Docker compose dev.yaml. Okay, so I need the development where okay, let me minimize this. Yeah, here, new file, Docker compose dot dev dot yaml. Okay, now here let me write services. Inside the services, let me write the Redis service. Okay, email will use Redis 7.2 alpha. Redis 7.2 alpha, yeah, this image. And let me give the container name GDS Redis dev. Okay, and let's expose the port 6379. Okay, then let me provide the health check. Let me provide it like this. Okay, health check. Now under the health check we need to provide the command cmd, then Redis CLI and ping. Okay, health check, great. Now let me provide here interval 5 seconds, then timeout 3 seconds, and retries 5 retries. Okay, now guys, let me provide here command as well. Okay, we can skip this command in the development mode, but in the production this is required. Redis server maximum memory, it should use only 200 MB, not 1000. Okay, maximum memory policy, all keys LRU and -- save. All right, now we can start this Docker compose, guys. So let me open the terminal and let me start the Docker compose. Docker compose -f. Forcefully, guys, I will up Docker compose -f, then Docker compose dot dev dot yaml up in detach mode. Okay, and before running this command, make sure your Docker engine is started, means you need to open your Docker desktop. Okay, and it should be hyphen detach mode. Hyphen D means in detach mode. Okay, and you can see Redis container is started. Now let's go to the Docker desktop, and there you go, Docker compose, and here our GDS Redis dev container is started. Great. Now let's go to our IntelliJ IDEA and the location service. Now let me start the all the services one by one. Okay, so all the services will start one by one. Till that, let me check the log of Docker desktop. This is our Docker desktop, and in under Docker compose we have the GDS Redis in development mode. Okay, let me check this. See, it says ready to accept connections TCP. Great. Now let's go to here. Our location service is what it says, data source attribute. Okay, I need to restart this. Then this is the airline core service. Let me restart this as well. Again, location service is throwing the error. What is this? Cache manager define in class path. It says you can provide one via Redis cache manager builder. Okay, so we need to provide the connection factory inside this builder. Okay, now let me restart the location service again, and I hope this time will not get any kind of error. Let's see what we are getting. Okay, so location service is started on port 5004. Great. And it's connected with the Redis. Now guys, whenever a user request for the locations, let me go to the location service. Where is our location service? Location service, yeah, city service. Okay, inside the location service we have the city service. Let's get all the cities. So first I need to log in. Okay, let me go to the login. I will log in with this detail. So let's log in. Localhost 5000. Let me check our API gateway is running or not. Okay, API gateway is running, but it's on port 8080. So I need to restart this because API gateway should run on port 5000, not 8080. Okay, so let's wait. All right, now API gateway is running on port 5000. Okay, let's go to the Postman and hit this, and we are getting this token. So let me copy this token. Now let's go to the get all cities. Okay, and here let me provide the airline admin JWT token. Let me remove this token and provide which we have copied. Let's save this, send the request, and there you go, we are getting all the cities. Okay, so first time guys it will give all the cities from our database. Once you hit again, this time it will give the all cities from Redis memory. Okay, so you can see it's quick, very quick. When I click on the send button, it's give me cities immediately within 34 milliseconds. You can see. Okay, so yeah, that means our Redis is working fine now.